Hello guys, welcome back to my YouTube channel. My name is Chandana and I am from Sri Venkateshwara College of Engineering doing my final year in electronics and communication domain. In today's session, I will be discussing about a topic like it is a paper, research paper, which is the topic which I'll be discussing today is an electromechanically reconfigurable intelligent surface for enhancing sub 6G wireless communication. Let us see what are the content which is discussed in this paper, which is also very useful for the wireless communication for especially for the ECE domain people. The contents which I am discussing in the today's session are introduction, history of technology, working principle, results, applications, conclusion, and the references. What are the references paper which I've used to build my knowledge on the given topic. Without any delay, let us get into the video. Let us see what is the introduction about an ERIS surface for sub 6G wireless communication. As we all know, in recent years, uh, popularity of smart devices, IoT applications, and the increasing information needs of people today, the demand of wireless communication quality has experienced unprecedented growth, which means in nowadays the smart devices, IoT applications, and also the information which is so much wanted to people has very high demand, and for to fulfill this demand or the needs of people, wireless communication is having huge uh, demand, and we need very experienced in wireless communication to increase the quality of service which we provide for the people and also to the industry and to the societies. That is what is explained in the point one. Next is one of the new solution attracting the most attention is the development of electromechanical reconfigurable smart surfaces to improve the wireless communication performance at the 6G. To meet all this demand, there is a new attracting solution which is development of electromechanical reconfigurable smart surfaces to improve the wireless communication performance under 6G. To meet all the needs like smart devices, IoT applications, the information that is needed by the people, there is a new solution which is evolved, that is the development of electromechanical reconfigurable services which will improve the wireless communication performance under 6G. The term here, let us see what is the term sub 6G means. Refers to the frequencies below 600 gigahertz. The term 6 sub 6G which means which refers to the frequencies which is below 6 gigahertz, which is an important frequency band for many wireless communication. As we all know, and the frequencies which is below or which is 6 gigahertz is very important frequency for the wireless communication. In this case, the use of ERIS is nothing but electromechanically reconfigurable intelligent surface is expected to solve the problem with exposure and coverage. So using ERIS technology, we expect to solve problems with exposure and coverage, especially in urban environments where the disturbances occur, which may result in which may which may result in the reduction of the problem. Thus, ERIS is expected to solve this problem, and also which gives the exposure for the coverage, especially in the urban areas where there are disturbances for the frequencies to travel, like there are obstacles. So, using ERIS, the whatever the problem which is occurred in or urban areas or rural areas, it will be reduced using ERS technology. This is the introduction about ERIS. Next, let's see the history of this technology. Like how did this evolve from the past years to the future? From past to future, how the technology has evolved. The evolution of ERIS for enhancing sub-6 GHz wireless communication tracks back to late 20th century metamaterial research. So in late 20th century, it is the research was depended on metamaterial research, focusing on materials designed to uniquely interact with electromagnetic waves. In late 20th centuries, the main intention of the research was to design the materials uniquely. Designing of the materials was the most important factor, which can easily interact with electromagnetic waves, that is EM waves. By 2010, the concept of dynamically reconfigurable RIS emerged. In 2010, the concept of dynamically reconfigurable RIS was emerged, promising to optimize wireless signal propagation in real time. The dynamically reconfigurable RIS, which was emerged, has a promising approach to solve the to optimize the wireless signal propagation in real time. That was This was the thing which was done in 2010. The adoption of RIS within sub 6G GHz spectrum, crucial for 5G and IoT, represents a significant leap forward, marrying material science with electrical engineering to meet growth demand for efficient, reliable wireless communication. To meet the needs for the upcoming future, they have focused on the material science and electrical engineering, which these two come together to meet the growing demand for efficient, reliable wireless communication. The main thing here is they focus on both material science and electrical engineering, which will, with these two focusing on the concept, we can meet the growing demand for efficient and reliable wireless communication. This is the history of technology. Next is the working principle. Like, what are the working principles which is followed in this particular paper? First thing is to design of the meta surface and driver module. Meta surface and driver module, these two are very important. Let us see what is the design of meta surface and driver module. For an electromechanical RIS, passive meta surface and driver module are the two indispensable component. So for ERIS, there is passive meta surface and driver module. This is the indispensable component in the whole system. Under illumination of incident EM waves, passive meta surface maintain the operating frequency of the whole system at eye level. When the EM waves is incidented on the passive meta surface, it maintains the operating efficiency of the whole system at eye level. Though when the incident EM waves is incidented on meta surface, then the operating efficiency of the whole system is maintained at a eye level. Driver module. Driver module offers a degree of freedom from manipulation of output EM wave response. This will offer the degree of freedom for manipulation of output of EM waves, EM response, and make the passive meta surface reconfigurable. This driver module make the passive meta surface reconfigurable and intelligent. Hence, it is called electromechanically reconfigurable intelligent surface. Since the driver module make the meta surface to act as reconfigurable and intelligent. Since the working mechanism of the passive meta surface determines the specific type of driver module, the working mechanism of passive surface will determine the specific type of driver material which is needed to use. When it depends on passive material working mechanism to select which driver module is required for the system. We start with the design of passive meta surface. After all this calculation, they start the design of passive meta surface. A mirror symmetric structure in box X and Y direction in the design of the high efficiency passive meta surface, and a typically square metallic patch is chosen as basic resonance structure. The material of metallic patch is copper with thickness of 0.018 mm. Here, the mirror symmetric structure in both X and Y direction, mirror symmetric structure with both X and Y direction, which will have high efficiency of passive meta surface. This is the configuration of passive meta surface. And a typical square metallic patch There should be a typical square metallic patch which is chosen as basic resonance structure. The material of the metallic patch is copper with thickness of 0.018 mm. Here you can see this is a schematic diagram. As you can see, this one is a schematic diagram. This is the passive metal part, the patch, and there is a mirror inside it which has both x and y direction. And the second is the driver module. This is the driver module, and this is the photography of driver module is the image C, and this will be the reflection phase, amplitude spectre with different values of air, reflection amplitude and phase response versus air at 2.55 gigahertz. Next, after designing the meta surface, passive meta surface and driver module, they have to do the numerical analysis of the RIS protocol. To verify the performance of the proposed design, we consider RIS prototype with 16 into 16 supercells. To analyze the performance, we consider RIS prototype with 16 into 16 supercells, benefiting from the capability of independent control for each supercell. The supercell which the RIS prototype which we choose, the each cell should have its own control and capability. The proposed RIS can be imposed in one dimension or two dimension. It is left to us phase profile and is capable of manipulating EM waves in the near and far field. It has the capability of manipulating EM waves in near or far field. Uh, and this is how the angle is calculated with using this formula. Phi of x comma y is equal to minus 2 pi by gamma square root of x minus x naught square plus y minus y naught square plus z square. Here gamma is given as the wavelength at 2.55 gigahertz. X and Y is the position of supercell. Based on this phase distribution, we retrieve that corresponding air according to the distribution of air can be opted. In addition to near field focusing, the proposed RIS prototype can also be used for various beam forming. The proposed RIS protocol can also be used for various type of beam forming. Here, the simulated result demonstrate that the proposed RIS supercell could provide stable and reliable phase modulation and may have excellent potential in efficiently manipulating EM field in different application scenario. Also, considering all the angles in which direction the air is distributed, we come to the conclusion that they have excellent potential in, like RIS prototype has excellent potential in excellent potential in efficiently manipulating the EM field in different applications of scenarios, in different scenarios. As the image you can see, different EM function is required for distribution of air. First one is given a simulation result of RIS base length with focal length of 200 meter. Next is B is calculated scattering pattern of a single beam with deflection angle of X, O, Z plane. And this next is the two beam deflected, and the next is the quad beam type, that is MH4. E to H is the required distribution of air corresponding to A and D. Like the upper portion, with respect to the upper portion, the lower portion is defined. These are the working principles or working methodology which they use to develop the RIS protocol. And here we have discussed the result. Beam format, in results also they have two different analysis of result. One is beam forming demonstration of RIS, which means in order to verify the actual EM performance and reconfigurable capability of proposed electromechanical RIS, a prototype with a size of 512 mm into 512 mm is fabricated, then measured in the microwave anechoic chamber to verify the actual EM performance. This prototype is taken and it is measured in microwave anechoic chamber. As clearly seen, each supercell is integrated with three motors and a motor driver board. When operating in power on mode, the 16 motor driver board on the back of prototype are powered in parallel by a voltage source with output voltage of 12. In this prototype, they have each supercell is integrated with three motors and a motor driver board. So 16 motor driver board on the back of the prototype is powered parallelly, and the voltage source with output voltage is 12 volt. The RIS prototype composed of 16 to 16 meta atoms has been released and successfully applied to solve the problem of weak signal, which is composed of 16 to 16 meta atoms, will be released and successfully applied to solve the problem of weak signal coverage of indoor wireless communication due to influence of complex indoor environment. This the evolved the evolved power, waves is been released and is successfully applied to solve the problem of weak signal coverage of indoor wireless communication due to influence of complex indoor environment, exhibiting obvious signal enhancement to sub 6G frequency band. This is the arrangement of uh, indoor module, and this will be the scattering pattern. This is the experimental demonstration of actual EM performance and reconfigurable capability of the RIS. The next category of which they analyze uh, the results is in actual indoor application scenario. Communication quality is often seriously regarded due to presence of walls. The communication is regarded due to presence of wall, corners or other fixed obstacles, which leads to NLOS area of signal transmission. Herein, we prove that the fabricated RIS prototype can effectively improve the signal quality of communication through indoor experiment. We test the proposed RIS in common scenario composed of a corner. Although such NLOS area is not typically enough due to indoor diffraction effect of low operating frequency, the signal intensity inside the corner is still weak relative to other location, and we try to demonstrate that the signal in this area can be efficiently enhanced by electromechanical RIS. So when there is an obstacle, the communication between the signals uh, is cut down. So here with when they have the weaker relative location, they demonstrate the signal in the area. When the location is weaker, they demonstrate a signal in the area where effectively enhanced by electromechanical RIS. We use signal generator to connect with transmitting horn antenna to generate directive wireless signal propagation, and use the omnidirectional antenna connected to the spectrometer to receive the signal. The ohmmeter antenna is connected to spectrometer to receive the signal which has been transmitted from horn antenna. This is an experimental demonstration of RAS assisted wireless signal enhancement. Now let us see the applications where our ERIS can be applied. One is enhanced indoor wireless connectivity, wireless broad access, secure communication, energy efficiency, augmented reality and virtual reality, wireless power transmission. These are the few applications of ERIS which is frequently used. One is enhancing the indoor wireless connectivity, like to increase the wireless connection in the indoor environment. Next is wireless broadband access, like broadband, like enhancing the wireless communication frequencies which is below 6G to provide the efficient wireless connection. Next is secure communication. Even through wireless communication, the data which is being transmitted and received should be secure. also which provides secure communication. Energy efficiency, here the energy which is used to power up is efficiently used and the consumption of energy is also reduced, hence it improves energy efficiency. Wireless power transmission, which also a main application for current scenario. This is the conclusion. By enabling dynamic manipulation of EM waves, RIS technology hold the potential to significantly enhance connectivity, security, energy efficiency across wide range of application, from indoor wireless network and IoT system to advanced 5G and forthcoming 6G deployment. As we move towards increasingly connected and smart environment, the role of RIS is facilitating reliable, high-speed communication becomes even more crucial. Beyond telecommunication, the implicates of RIS extends into areas such as remote sensing, healthcare, power transmission, highlighting its broad impact on and potential. As research and development continue, the future of RIS technology promise not only to meet the growing demand of improved wireless communication but also to open new avenues for innovation across multiple sectors. These are the conclusion from studying the proposed papers. And these are the reference papers which we have referred for gaining the knowledge about the concept electromechanically reconfigurable intelligent service for sub 6G wireless signals. Thank you for the thank you for watching this video. I'll be back with other video with another interesting topic. Till then, please don't forget to like, share, comment, and subscribe to my channel. Take care.